everyone, and welcome to the Physics of Superheroes. On this very exciting episode, we will be discussing one of Marvel's most popular superheroes, Iron Man. Iron Man was created by Tony Stark, an American billionaire, industrialist, and genius engineer. In the first Iron Man movie, he created the Iron Man suit in order to escape from being held captive by terrorists. Ever since then, he has made more and more advancements in the suit to make it look and perform better. There are 3 movies so far in this series, all of which have Stark going on multiple adventures that include flying around and fighting the bad guys. In this video, we will be discussing how Tony Stark is able to fly in the Iron Man suit. By describing the mass and weight of the suit, along with the forces that act upon him while he's in the air, we will describe his velocity and how much force is needed to make him accelerate.
In the Iron Man movie, we see Tony Stark fly in a suit alongside a jet aircraft. This means he can achieve at least Mach 2, which is 680.58 meters per second. The mass of the suit and Tony together is approximately 300 kilograms. Now with this information, we can draw a force diagram and solve for the amount of force the 4 of the thrusters on the hands and feet of his suit need in order to push him to the speed. Let's start with a motion map. We know that he is going at a constant speed or constant velocity, so the motion map dots will be equidistant to each other. Now we can draw a force diagram. Condense Iron Man into a dot. The first force that is acting on him is the force of gravity. Then you have drag, or air resistance, and an equal force of the thrusters. Now opposite to the force of gravity is the force of lift, which is equal to weight. The equation to find the weight acting on an object is weight equals mass times gravity, where gravity is 9.8 meters per second squared, and mass is 300 kilograms. This makes weight equal 2,940 newtons, which also makes the force of lift 2,940 newtons. Now we have to calculate drag. The equation for drag is drag equals 2 times density times velocity squared divided by 2 times the surface area. At around 30,000 feet, the density of air equals 0.000891 kilograms per meter cubed. The velocity of Iron Man is 680.58 meters per second. The surface area of his face is 0.05 meters squared. When you fill in the equation, it all multiplies out to equal the drag. Drag is equal to 20.635 newtons. By finding the drag, you also find the force of the thrusters. Let's look at what occurs when the forces are unbalanced. In the Avengers, we see Iron Man flying next to a missile, traveling at hypersonic speeds, approximately 4,023.36 meters per second. How much force would be needed to accelerate from 680.58 meters per second to 4,023.36 meters per second in 10 seconds? Now we know the force of lift, drag, and weight. Let's make another force diagram representing unbalanced forces. To calculate an unbalanced force, use the formula force equals mass times acceleration. And acceleration can be calculated by the formula acceleration equals final velocity minus initial velocity divided by time. Plug in the final velocity of 4,023.36 meters per second, the initial velocity of 680.58 meters per second, and the time of 10 seconds. From this, acceleration is equal to 334.3 meters per second squared. Now plug mass and acceleration into the formula force equals mass times acceleration. From this equation, you acquire the net unbalanced forces of the thrusters and the drag in this situation. To get the force of the thrusters, subtract the drag, 20.635 newtons, from the net total, 100,290 newtons. The force of the thrusters is 100,269.365 newtons.
So now you know how much force it takes for Iron Man to fly. By calculating the drag, we were able to find the force of the thrusters in the balanced force diagram. We were also able to calculate how much force the thrusters needed to go from one velocity to the other in 10 seconds using the unbalanced force diagram. Join us next week when we explore the physics of Spider-Man.